Hello everyone, it's 2:50, so we are ready to start. Before introducing our amazing speaker, I would like to remind you that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speaker after the presentation. So welcome everyone to this NLP Summit. My name is Nadia and I work at NIDAS as a senior machine learning engineer. And I'm really passionate about NLP. Today, I'm honored to be here and to have the opportunity to introduce one of our amazing speakers. And our speaker of today is Heng Ji. Heng Ji is a professor at Computer Science Department and an affiliated faculty member at Electrical and Computer Engineering Department at University of Illinois at Urbana-Champaign. She is an Amazon scholar. She received her BA and MA in computational linguistics from Tsinghua University and her MS and PhD in computer science from New York University. Her research interests focus on natural language processing, especially on multimedia multilanguage information extraction, knowledge-based population, and knowledge-driven generation. She was selected as Young Scientist and a member of the Global Future Council on the Future of Computing by the World Economic Forum in 2016 and 2017. The awards she received include AI's 10 to Watch award by AEEE Intelligence System in 2013, NSF Career Award in 2009, Google Research Award in 2009 and 2014, IBM Watson Faculty Award in 2012 and 2014, Bosch Research Award in 2014 and 2018, Best of ICDM 2013 paper, Best of SDM 2013 paper, ACL 2020 Best Demo Award paper. She is elected as the North American chapter of the Association for Computational Linguistics secretary in 2020 and 2021. She has served as the program committee co-chair of many conferences, and she has been the coordinator for the NIST TAC Knowledge-Based Population Track since 2010. Please join me in welcoming Heng Ji.
Thank you so much, Nadia. So I would like to talk about our recent project. It's called Information Surgery. It's basically trying to detect fake news from multimedia documents. And we want to do this on fine-grained knowledge element level. And this work is done by my PhD student, Eden Feng, based on her ACL 2021 paper. And it's based on collaboration with Professor Xi Qiang and Columbia University. So the motivation of doing misinformation detection is very clear because we are living in an information pollution era. In the very old days, when we were facing information pollution, we had no evidence to really argue what happened and what did not happen because of the lack of the data. So this is an example to show that in Japanese history book, they usually don't talk about how many people died in World War II when they were invading China, because different people have different interpretations, depends on their stance and then their bias. So for us, it's really important to know what happened, and we want to assist historians and librarians to create more complete and authentic history books. So that's the ultimate goal. And the information pollution problem is even more serious right now. So this is another example. This lady, she was the first one to get vaccine in UK, and there was some rumor on the Twitter saying she died, and many people actually believed it. And she had to come out and say, "I'm still alive. I'm super healthy, super happy." And sometimes this kind of misinformation can, cause a lot of threatening and cause violent events. So, for example, this woman soldier, she was attending this sports event in October in Wuhan, and she was falsely accused as patient 0 just because of the connections between that sports event and the disease outbreak. Even though she was never tested positive, some people still believe the misinformation. So why human are still good at connecting dots, and why they believe this kind of rumors? So the reason is because usually the human-created misinformation is not 100% false. Actually, most of the information is true, but they try to manipulate some small pieces of the document, so some certain knowledge elements, so to make it fake. For example, this news article is about Simone Biles. So she quit from some games in Olympics, and this document is talking about she got pregnant, which is completely false. But most of the other information in this document is true. So a lot of people just believe that the information and all the information is true. So this kind of misinformation can spread really fast in other languages as well. So this shows a Chinese article that was posted right after the English one about the same misinformation. So I know it's really hard to do interaction using this interface, but if you like, you can still post your answer in the chat and we can talk about them later. So I would like everyone to take a look at these two documents. They are about the same topic, and one of these two documents is fake. As a regular news reader, if you don't keep track of what's happening in Burmese news articles, it's very hard to tell which one is true or fake. So the highlighted part on the right side show the different information from the left side. So you can see there's a different relations between this organization, and there's some new event. For example, winning election, or maybe make a statement. So how do you think, left or right? Maybe you can post your answer to chat and we can see who answered right. So so the correct answer here is the right one, is fake news. So all these red parts were actually created by human, and they are all false information. So here's another example. So a lot of misinformation is actually appearing in captions, because usually when we read a news article, we check the image and the captions first. So just look at this picture. It's hard to tell whether the soldier just arrived at this place or they left this place. So the fake information is the left the facility, so they actually just arrived. But if you cannot see clearly the facial expression, or maybe if you have no idea what this facility is, then it's really hard to tell just from the image which one is fake. Similarly, sometimes we need some background knowledge to infer which one is misinformation. So for example, here, for this image, one says this place is in Milan, the other one says this one is Berlin. And if you know a little bit about Italian, maybe you can see this brand is written in Italian, and maybe if you have been to Milan, you can see these beautiful old street scenes, and maybe you are familiar with this brand, and you can tell maybe this should be in Milan, not Berlin. So we need to teach a model, a machine, to automatically detect this kind of misinformation on the knowledge element level. So previous work usually only look at the document level. They will look at the whole document and say this is a fake document or not fake document. And they usually only look at one data modality, which means they only check the natural language side or only image or video side. So we propose to do fake news detection on knowledge element level, which means we not only tell you this document is fake, and we also explain why we think it's fake, which part is fake, and how can we fix it. And the most important evidence here is to gather the information from multiple data modalities, and we will do information consistency checking. So here's just another example. We're showing you a news article about the Hong Kong protest. So what we can do is we look at multiple elements in this document. We use the venue, the journalist name, time, and the title, and look at image and caption and body text. So we are going to convert this whole document into a multimedia knowledge graph. And then the task is to look at every triplet in this graph, so which means an edge connecting two nodes, and try to classify each triplet as a fake information or true information. And then we also have a traditional task to classify the whole graph as fake or real. So to do this task, we have two challenges. The first one is we don't have any existing information ingestion system to build that kind of multimedia knowledge graph for news domain. So we either have some training data from natural language side or maybe from image side, but we don't have anything for multiple data modality. So the solution we propose here is to build a multimedia common semantic embedding space so that you can do cross-media knowledge transfer, and I'll talk about that later in details. And the second challenge is that similarly in developing this detector, misinformation detector, we don't have any training data because usually human-written fake news documents will be removed immediately after they are posted. So we'll need to figure out a smart way to generate fake news documents automatically and try to mimic what a human will do and then use that to train our detector. So for the first challenge, we collected millions of image and caption pairs from 15 years newspaper. And then for every image, we will run a system called a situational recognition system. So this system is very similar to what we normally do in natural language on semantic labeling. So it will basically label every image with a verb. So they defined about 1,000 frames from FrameNet. So for example, this image is corresponding to the throwing frame, and they will identify these bounding blocks, these regions, as certain corresponding semantic roles. For example, this part is a man, and this man is played as agent semantic role. So one thing to note is that existing object detection systems cannot cover all the scenarios in news domain. So we decided to add a visual attention map. So basically for anything that's not explicitly recognized as object, we'll identify the visual heat map. So for example, this red part, the heat map shows this is an item. And then for the caption, we'll do semantic parsing. So we choose to use abstract meaning representation parser that can give us 140 types of relations of edges. So we get a rich graph from the original caption. And then we use graph convolution network to encode this graph from text and this graph from the image and map them into the same common embedding space. So here you can see that natural language label really serve as a bridge to connect these two data modalities. So for example, we can see maybe the bus heat map is very close to another vehicle that happened in the that occurs in the caption. So after we construct this multimedia embedding space, we can then merge all the training data we have from natural language and from text and from image. So this is the corpus that's manually annotated about events and entities in natural language. And this one is the situational recognition corpus. So they annotate the images with the semantic rows. We are going to use the common embedding space to both corpora and then train a classifier to detect events and argument rows for any new article during the test phase. So in the test phase, we don't require the image and the body text to be aligned or caption to be aligned, as long as they can be encoded using this embedding space. And then this serves as a unified joint model, and we simply apply that to any new multimedia news articles. So we use this to construct the multimedia knowledge graph. And now we are going to look at every triplet in this graph to determine whether it's true or false. For example, we will look at this triplet that says there are places shooting at people, but this one is not consistent with what we observed in image, because in the image, we don't see the shooting event. So in that case, we are going to determine this as a fake triplet. So to do this kind of a fine-grained classification, we need a lot of features. So we leverage two types of features. The first one is look at the global content, basically look at the whole graph. And this graph will be, each node will be initialized by the embedding representation from our multimedia embedding space. And then we use graph neural network again to propagate their information from one node to their neighbors. And then we also look at the local representations from all the entities and relations events we get from the source context. So let me walk through step by step about how to do this. So we first, for example, we'll take a look at the caption and run our multimedia information ingestion, construct a relation triplet and another event arguments, and then we do cross-media linking. So for example, here there's a bounding box can be linked to the place we identify from caption and body text, and there's a shooting event mentioned in the caption, and that will be also linked to another shooting event mentioned in the body text. So this merge-notch graph can help us determine which triplet is inconsistent with their neighboring triplets. So in order to enrich the representation, we also link all the entities and the concepts to external knowledge base that will include Wikipedia, Wikidata, and some GeoName database, so that we can gather knowledge from historical events and the human curated knowledge. So for example, Hong Kong police will be linked to some external documents, and we gather additional information to represent Hong Kong police. And then after we have this graph, we are going to do information propagation to check the consistency. So we will do that within each data modality first, and then do cross data modality. And then gathering both the local and the global features, we will use them to do classification. So we will classify, for example, this one physical located near this relation is correct, but maybe near the hidden corner is not correct. And using the background knowledge, we also can determine the attacker is unlikely to be arrested. Attacker is likely to be arrested, victim is unlikely to be arrested. So we can use that to determine this arrest information is correct. So that's how we can do the detection. But to train this detection, these classifiers, we need a lot of training data. But the problem, as I mentioned at the beginning, is we are lacking of manually created fake news documents. So we decide to mimic how human would generate fake news documents and generate training data automatically. So the idea is to obtain an authentic knowledge graph from authentic real news articles. And then we do knowledge graph manipulation. And then using this fake knowledge graph, use this fake news knowledge graph as condition to generate a fake document using language models. So the manipulation operations we have done include entity swapping. So which means we are going to look at any entity and then replace it with another entity that has similar embeddings. Or we are going to introduce a new relational event involving the same set of entities. Or sometimes we also can replace the subgraph with another subgraph coming from another news articles. So the problem of information ingestion is usually it's targeting at a limited ontology. So in order to increase the coverage, we also try to add some constraints. So for example, if we simply replace bicycle with a truck, either human or the machine detector can easily detect this as misinformation because truck is not grounded in the image. The image clearly shows it's a bicycle. So we try to avoid the entities which are already grounded in the image. So for example, we are going to replace Zambia with Fiji because this country is not grounded in the image, and these two countries are semantically similar in our embedding space. And then use this new knowledge graph, a fake knowledge graph as input to condition our natural language generator, we can generate this fake news document. So in order to increase the coverage of IE in constructing knowledge graph, we also use abstract meaning representation parsing again to do more manipulations. We are going to replace some semantic rows, and sometimes we also add a negation. For example, here initially the event is about attack. We will replace that with a hiding and also replace some arguments and generate a new caption. So I just want to make a quick statement here. We are not going to share our generator with any researchers or any human users, but we have shared our detector publicly so that no one can use our generator to do bad things. So to check the quality of this generator, we also did a tooling test in which we show a pair of real article and a fake article to human readers and ask them to determine which one is true and which one is fake. And we found that human can only find 42% of the fake documents. So which means our manipulation is effective. So we compared our model with the two previous state-of-the-art fake news detection models. The first one is called Grover. So they used language modeling to generate fake documents, and they used linguistic features from language modeling to determine the document is fake or not. And this Dedan model is from, so the Grover is from UW, Dedan is from Boston University last year MLP paper. So they look at the image features and together with the language model features to determine fake news, each document is fake or not. So we applied our model to the data set generated from Grover. So this is based on language modeling, did not use any knowledge graph. We can see our performance is higher. And also we tested on our own fake news generated from our generator. We can see our performance is so higher and our data set is harder to detect for our model. So the knowledge element level performance is still quite low, 37%. So there's a huge room to improve, but at least the document level detection accuracy is much higher and our results are much more explainable. So here's another example to show how it works. So this facility, Twin Towers, is not grounded anywhere in an image, and our model can successfully detect this piece of information as a fake information, and the model that only use service visual features or language models fail to identify this as fake information. So just want to quickly mention a couple of ongoing lines work. The first one is that we not only want to detect the misinformation, we also want to identify the intent or characterize the intent motive behind the misinformation. Because sometimes, you know, it's just because the writer did not have enough background information, so they missed some important part, or sometimes they just want to set up an agenda. Sometimes they just want to do some propaganda, or maybe just try to, you know, exaggerate the emotions, or maybe try to trigger some moral concerns, or just to deceive readers. So it's important to really characterize different intent motive behind the misinformation so that we can prevent similar things from happening again. And another important task is to collect the misinformation. So we are doing two types of collection right now. The first one is if this misinformation, we clearly know it's fake, but we don't know how to fix it, we're going to remove it and then create an authentic document. But if we can compare the misinformation with the related documents and somehow figure out the authentic version of it, then we can also correct the information by gathering the real information from the original document together with the background documents and generate the correct information, regenerated document. And also, we did not really do cross-document consistent checking, so that's ongoing work. We are looking at across documents and even from different languages so that we can further verify the information from different sources. So I mentioned that we used some information about the journalist, the publication venue and the time and the location, but we did not really look deeper than that. For example, we probably should look at the political stance or bias or the aspect or moral values of this narrator, and then use that as another dimension or evidence when we are trying to classify the triplet. And the other perspective is the context. So we only look at time location, but sometimes we probably should look at the background of writing this article, or maybe whether this article is under censorship. So we need to look at why the content. And then the idea is to do a tri-hits algorithm to propagate the credibility across these different dimensions. So our system is publicly available in the first link, and the other components such as how to build the information injection system, or the neural multimedia event injection system, everything's available as a Docker containers. Okay, I finished earlier than I expected, so I can have plenty of time for questions. Sorry, future work. I talked about some ongoing work already. So I think overall it's a very challenging task, but I think it's a very important one, and we should work on it together. And so in the future, I talked about looking at the cross-document information consistent checking, and we completely ignored the discourse level linguistic style analysis in our work, so we should incorporate that, and also incorporate background knowledge and maybe also common sense knowledge. And in our fake news generation, we did not capture all the perspectives of how human created fake news. So, for example, human usually will introduce a lot of novel entities, and when the readers look at some information that they never heard of, they usually don't have time and patience to check, and they just tend to believe it. So, and also human usually try to include a lot of details when they elaborate the fake information. So, and they try to make this very engaging. So this kind of styles and the level of details should be also considered in our detector and generator. And I talked about intent detection, and also the ultimate goal is really try to build a comprehensive platform so that whenever people get confused about some information, they come to this platform and check our multi-view summarization results from this after we fix the misinformation. And ideally, if we also know what is our target population, target audience, we may select a subset of authentic information for them, and everything should be delivered in an authentic way. But we are not trying to replace journalists or replace historian, but we hope this platform can serve as a knowledge distillation kind of tool so that they can gather a small part of it and the authentic part so that they can speed up their writing or summarization, their task. And for any human readers, this probably is a consultation kind of platform so that when they are confused from multiple sources, they can consult this result. And then this platform can serve as a human curation interface. People can come here to edit, and yeah. So that's a grand vision, and we are still far away from that ultimate goal. And as you can see, I showed about techniques coming from NLP and computer vision, machine learning, and graph neural network. So we need a lot of collaboration from the whole community to work on this together. Yeah. Thank you, and I will be happy to take questions.
Thank you so much, Heng. It was really an interesting presentation. I really enjoyed it. So we do have one question in the chat that says, not all fake news would have images associated with them. Also, images in the news would not be exactly related to the fake news we are detecting. How do we tackle that?
So for the first question, you're right. So when we don't have multiple data modality, then if there's some inconsistent triplets from, for example, body text, we will be able to detect that. If not, then we'll have to rely on other related documents. So for example, you have to check the related events and do anti-linking, link to the external knowledge base and gather additional evidence. Yeah, so the cross-media is really just one angle of the signals we can gather. Yeah. And the second comment is a very good one. So that's why I think our traditional definition of fake news is quite vague. Sometimes the journalists just did not get time to watch the whole video, so they misinterpreted some facts in the video. That's also possible. So that's why we need to further categorize this into different intent and motive. So that's part of our ongoing work. But in this paper, we didn't do anything about it. Yeah, so that's a great point. That's exactly what we need to do next.
Okay, thank you so much for your response. There is a kind of a follow-up question that says, in some case, we can have fake images along fake news. What changed in this case?
Yeah, so that's a great question. So I'm an NLP person, so I did not do any manipulation on the images. But in our project, we have so this is a big project, and then we are doing detection, and our counterparts, we have several startup companies and Google. They are doing their fake image and fake video generation. So whenever we improve our detection technique, they will improve their fake image and video generation components. So in our input data, we do have a lot of fake images and fake videos. And we, at this moment, we don't distinguish them from, like, say, fake text. We just simply construct multimedia knowledge graph and detect, for example, this bicycle is photoshopped. Then we can detect that if it's not grounded in the body text. But ideally, we want to also, incorporate some lower level computer vision techniques, right? Maybe you can do reverse engineering, try to figure out how, maybe this bicycle just looks strange in this setting, then maybe that can give us additional signal. So we haven't done anything on that yet. And we found fake videos is very, very tricky to detect, because sometimes, for example, they will put a fake speech for this speaker, and the whole video is just about this person's face, and then it's just very hard to detect that's fake or not, right? Because the only signal you have is the speech content. Yeah, so there's a lot of remaining work to do. Yeah, thank you for the suggestion.
Thank you so much. Okay, so we have now a more technical question. What tech stack or open source tool do you use?
What open source tools? So for all of these graph neural network algorithms, so I talked about we use GCN, right? Graph convolution network. So I'm not a machine learning person, so we use some tools from other people. I actually highly recommend if you search graph deep learning from graphs for NLP, you will find a very comprehensive GitHub page. It's done by my collaborators. They released a lot of tools for graph neural network. So we use a lot to encode this comments like embedding space. And also here, when we are looking encode the features, we also use some CN. So these machine learning tools, we used other open source toolkits. Yeah. And our low level, for example, the feature encoding and the detected, for example, the cross-media coreference, all of these things are shared publicly in the final page I showed. Yeah, so all of these are open source code, and we also shared Dockers for people to run without compilation. So yeah, you're welcome to try them out and send me feedback.
Thank you so much. A lot of information. There is also a more specific one. Which off-the-shelf AMR model do you use?
What is MMLA model? Which open source knowledge graph? Is that the question? Or AMR model? AMR model. Okay. Yeah. So we used the IBM model. They had a paper in MLP 2019 or 2020. I don't remember the exact year, but I can send you email if you drop me a note. And we have the final version of the AML corpus we got from our project, and we retrained IBM model from that data. And so that AML parser is also publicly available in another paper, and I can send a link if anyone is interested.
Okay, so yes, the last one is the one related to the open source knowledge graph. Which one will you use?
Yeah, so we used Wikipedia, Wikidata, and the GeoName database, and there's another database called World Factbook. So basically, it's about people, organization, location, those entities, and then we do automatic interlinking, link the concepts and entities to those pages, and then from there we gather the properties, info box, and the definition sentence for those entities as additional representation.
Awesome, thank you so much. This one was the last question, so let's wait just a minute to see if anybody else has another question. Meanwhile, I want to say thank you again, because it was really interesting to listen to your work and your presentation. And yeah, thank you so much.
Thank you so much, everyone. Good time. Yeah.
Okay, no more questions, so bye.